In this video, I'm going to be explaining about how to be able to get the complete dimensions of a floor plan that has maybe only one or two dimensions. So for this very floor plan has only one dimension on it, and the rest of the spaces that are here, the rest of the functionalities that are here does not have any dimension. So let's say, for example, a client brought a design for you, and this very design does not have any scale indication of the scale, and also it does not have dimensions on it, and it is not a soft copy, just a hard copy. That's what the clients give to you. So how will you be able to solve this very problem? This method, for you to be able to solve this very problem, you have to be able to get the dimensions of the rest of the spaces, because you cannot be able to design with exactly with only this very dimension here is 3 meters, which is 10 feet only for that space. So I don't know the dimension of the living room, I don't know the dimension of the veranda, I don't know the dimension of the toilet, I don't know the dimension of the dining, of the bar, the dimension of the dining, I don't know the dimension of the kitchen, I don't know the dimension of the store, I don't have know the dimension of this other living room, dimension of the toilet I don't know, then the dimension of the kitchen I don't know, then the dimension of this bedroom also I don't know, dimension of this toilet I don't know. So, and it has only the dimension of the garage. But if it's a soft copy, you can be able to dimension it out, take it to your AutoCAD software and dimension that. For this very problem is when you are given a design and it's a hard copy. I mean, if I say hard copy, I mean a printed copy, not that it's the soft copy that is the AutoCAD software file. No, for this very one to be a printed copy, the person definitely, the client printed it out and just like a picture and send it to you to design for you, and they say the client wants exactly the dimension that is present there, of which the dimension is not shown here. The only dimension that was given to you is just, let's say, one or two dimensions. So this one has only one dimension here, and you are told to be able to get the exact dimensions of the rest of the spaces, of which it becomes a problem if, since it's a hard copy and you cannot be able to dimension it out. So I'm just using my AutoCAD software to explain this very problem, and so that I can be able to explain also the solution to the problem. Let's say it's a hard copy, although I'm supposed to sketch it out and start explaining, but with this you can be able to understand exactly what I'm trying to say and provide solution to it. This, in case you have such problem, you know how to be able to handle it. So for this very one, we have 3 meter. So it's with this 3 meter I can be able to generate the rest of the dimensions completely, so that I can get the accurate measurements of the rest of the spaces. So since I already have this dimension to be 3 meter, with this 3 meter dimension I can be able to get the dimensions of the rest of the spaces that is present here. So how do we go about that? The first thing you have to do is, since we already know the dimension of the dimensions one of the dimension, then we can be able to get the rest of the dimension. So we are going to make use of this formula. Unknown dimension, which is the dimension we are looking for, is equal to known dimension, sorry, the formula is unknown dimension is equal to known measurement of unknown dimension multiplied by known dimension divided by known measurement of known dimension. So this is the formula. Just write it at the side so that I can be able to make use of this formula anytime when you are trying to get it. So how do we come about this unknown dimension? Unknown dimension is the way we're able to get this formula is the known dimension is equal to known measurement of known dimension. That's known dimension equal to known measurement of known dimension. What it means is the known dimension, which is the dimension that is already known, which for this very one problem we are trying to solve, the known dimension here is this 3 meter or 3000 millimeter is the known dimension. So known dimension is 3000 millimeter. Now known dimension, which is the 3000 millimeter, is equal to known measurement of known dimension. Known measurement of known dimension, that's the you have to make use of your make use of scale. You make use of your rule and take measurement of this very space. You measure from this point where the dimension line is. You measure it with the use of your scale rule. Measure from this point to this point. That's on the hard copy. That's the paper, the printed copy. So you take measurements from this point to this point. Whatever measurements I gave to you on paper, whatever measurement that you got on paper in regard to this dimension, the measurement that you got is the known measurement of known dimension. I hope you understand what I'm saying. Known dimension, which is this 3000, is the known dimension. That's from here to here is 3000, is already known, which is known dimension, is equal to known measurement of the known dimension. This dimension is already known. Now we have to measure the known dimension space. That's the space that has been dimension and it's already known. You measure it with the use of your scale rule, the space from the dimension. That's from here to here is the dimension of this 3000. So I'll make use of scale rule to measure from this point to this point on paper, because now we are working on paper, it's not on system. Assuming it's on system, just take your measurements and get it immediately. But now we are trying to get the rest of the dimensions. You have to take measurement from of a known dimension with the use of your scale rule. Whatever measurement that you got there becomes your known dimension, known measurement of known dimension. So after getting that, the next thing is how we got this formula is what I'm trying to explain. Now known dimension is what here. Unknown dimension means the dimension we are unable to get, which is the unknown dimension, is equal to known measurement of unknown dimension. What it's trying to say is unknown dimension means this is the unknown dimension. Let's say I'm trying to get the dimension of this living room. Let's say I'm trying to get the dimension of this living room. Unknown dimension. I don't know the measurement of the width. I don't know the dimension of the length and the breadth of this very space. So let's say I want to get the length of this place or the breadth of this space. Unknown dimension, there is no measurement. It does not have the unknown, meaning that the dimension is not known, does not have any measurement. So it's called unknown dimension. It's equal to the known measurement of the unknown dimension. Okay, this unknown dimension, whether it's the length or the breadth of this living room space, unknown measurement of the unknown dimension. So the length is unknown, then the breadth is unknown, the length and the width is unknown. So I'll have to make use of my scale rule and measure the space for the whatever, whether it's the length or the width of the space. So I will take the measurement with use of my scale. Whatever measurement that I got there becomes the known measurement of the unknown dimension, that's of the dimension that is not known. Then the formula becomes unknown dimension is equal to, then the next step is to cross multiply. When you cross multiply, and we are looking for unknown dimension, when you cross multiply, unknown dimension becomes equal to known measurement of unknown dimension multiply by what? Known dimension. See, then divided by, for you to get the unknown dimension, for unknown dimension to be standing alone, you have to divide it by this known measurement of known dimension. So it becomes divided by known measurement of known dimension. That becomes the formula. So with this formula now, unknown dimensions becomes known measurement of unknown dimension. Unknown dimension, the measurement. Let's say for example, I'm trying to get the store space measurement. So let's say I'm trying to get this space, let's say from here to here. Then looking at our formula, unknown dimension of that space, known measurement of unknown dimension. So I have to take measurement of this unknown dimension with the use of my scale rule. I measure from this point to this point with my scale rule. Whatever measurement I got there, then I will now multiply it by known dimension. So known dimension, the dimension that is known, which is this very one, which is our reference point. So I will always going to be referring back to this dimension that we know. The multiplied by known dimension. What is the known dimension? Known dimension means the dimension that is already known, which is 3,000 or 3,000 millimeter or 3 meter, multiplied by known dimension, which is 3 meter. Then divided by known measurement of known dimension. That's, it's trying to say that I have to go to this reference point, then take the measurement from this point to this point, get the measurement. Then you now becomes overall division of this known measurement of known dimension, which is the measurement that is present from here, from this point to this point. Yeah, I'll write it down. So that's how I get my unknown dimension of that very space of the store space. So that's how I'll be able to get it. So with the use of this formula, you can be able to get your known dimension for all these spaces, both the length and the width of each of the spaces. If you apply the formula, you can be able to get it if you understand it. So for you to be able to use this formula that I explained for now is based on if there is an individual dimension, maybe there is one or two dimensions that is present on the floor plan, then you have to make use of a formula to be able to get the rest of the measurements. You see that after applying this formula, you can be able to get the exact dimensions of all the spaces without you guessing on the exact space. If you have not subscribed to this channel, go ahead and subscribe for more content.